right, I guess we can go ahead and get started. Seems like the beeping has slowed down a little bit. So this is Jill Leckett. I'm here with Dennis Ojima and Gabriel in the Climate Science Center here. Yeah. And Shelley just walked in. Today we have Imtiaz Ghazwala and maybe Joe Barsugli, I understand, who are going to give us an update on the workshop on high-resolution climate modeling in the Northern Great Plains that they held. I believe it was at the end of last month. They are the co-leads for the Climate Foundational Science area. I guess we'll just have Imtiaz get us started here.
Okay. Well, good morning, everyone. Thanks, Jill. So this is really a briefing on this workshop we did about a month ago. And by we, I mean myself, Joe Barsugli, and Candida Davis, all part of the Climate FSA team. And I just want to acknowledge funds for the workshop came from the grant we have from NCCSC, and also, the support we got from Ceres at CU Boulder, and the NOAA's Earth System Research Lab for the space and logistics. And I've put the website out here, and it's also in the abstract if you are interested in getting more information about, the agenda, and the participants. Okay. Just trying to move slides. Not able to move. Okay. Here we go. So what we will cover will be kind of a briefing on motivation, who was there, how we did it, and really then the latter half of the presentation is what really came out in terms of what are the right kind of questions we should be asking, issues and insights that emerged. So a little take on what are these high-resolution climate models. So they come in different flavors. More typically, they are what we call the regional climate models. Most of them in the recent past have been close to half a degree resolution. That's about 50 kilometers in our region, and more recently closer to 25 kilometers. But yeah, if you look at what's out there in terms of output, most of the output is coming from this kind of resolution. So what you have here is over a region we run these regional climate models, and at the boundaries you kind of provide output from GCM. So it's kind of a one-way output from GCM typically, and a regional model is using that information and doing modeling within a specific region at a higher resolution. And same concept as you go to even higher resolution. Here I'm turning ultra-high resolution modeling that's been done selectively over regions. And there you can have multiple domains going from fine to finer. Here, as I'm just showing an example, 30 kilometers to 3 kilometers. So you really, in your domain of interest, you're running it at a very high resolution. But again, you're providing this information at the boundaries, something like a weather model. So again, the idea is to dynamically downscale a GCM, and that's what these models are doing. And instead of just what the other way, what we do is more of the statistical downscaling, which involves all kind of simple, very simple downscaling to very complex statistical downscaling.
One question?
Yep.
This is Joe. I just wanted to add one thing. There are also other models out there which we didn't really cover there. But there's actually a global coverage at maybe 25 kilometers, but those are not yet being run for long enough periods to do full-on climate scenarios. So, and there's people who there's many other configurations we didn't talk about, but the salient issue here is that they actually simulate the weather, they simulate the winds, they simulate all the rainfall and all these processes at the scale of the model, compared to the statistical models, which are often using only a few predictors, and they're not based on physical processes, they're based on statistical relationships. So that's the salient issue of high-resolution climate models and why we adopted this catch-all term, that because the field out there is growing and evolving pretty rapidly. I mean, it's not just traditional RCM downscaling. But for the purposes of this workshop, people at the workshop represented these two different approaches, basically.
Right.
Yeah.
There was another approach also that Scott Denning presented, but with running at a GCM scale, but having a fine film of very high-resolution modeling, so that was another flavor. But the idea is really capturing the process at the fine scale and in a physical manner. That's the idea of why we need these high-resolution models and where we need it is what this kind of workshop was all about. I was, again, having problem moving my slide here. Okay, I guess it just leaves. I should use the mouse. So the motivation is, what's the current state of the art for the HRCMs? And so we really wanted to get there, get everybody on the same page on that, but really with focus on the north central regions, the Great Plains primarily, but also the mountains. And so one of the questions we wanted to ask was, what are the critical information gaps that the HRCMs can fill in these regions, and the ecological impacts relevant to these regions? And so just getting a better understanding and quantification of those impacts. Are HRCM better than some of the statistical products that we are using? And finally, the emphasis was on what are the salient questions, what are the right questions that we should be asking, and what are the insights that are already emerging from these models that we should be considering. So who was there? We had primarily two groups of people. There were climate modelers and what we call the expert users of climate information. We had them in almost equal numbers, and we had some of the really big names when it comes to the regional climate modelers, people like Linda Mearns, Roy Rasmussen from NCAR, Bob Oglesby, and Scott Denning from CSU. So we had some very, big names, and people have thought a lot about the modeling. And again, it was good to have them alongside the ecologists and other expert users of these data sets to have this conversation. We held the meeting at the NOAA's Earth System Research Lab in Boulder just about a month ago. And as it was about what I call a day and a 1.25 day workshop, almost 2 days. And the first day was mostly, having short presentations and long open discussions, including panel discussions. And the second day was mostly a working session with breakouts and reporting from breakouts. And we had, a lot of good note takers out there. We really wanted to document the process very well. And I'll share later that it's one of the products that comes out of this workshop. It's an evolving document. So the workshop, as we were planning for it for months before the workshop, it was put into 3 categories. As we initially thought, maybe we could just focus on convective precipitation, but then as we got more into planning for the workshop, we kind of put them in these 3 topical areas. Convective precipitation, which again we felt was very important for processes in the Great Plains, but also another category of which we defined as land surface processes and feedbacks. Again, thinking drought here primarily, and are we simulating the process relevant to drought properly? And finally, the issue of usability. And initially we thought we'd just have climate modelers, but then again, we considered maybe having these expert users and really discussing the issue of usability more deeply. And so these were the 3 topical areas, and in the agenda we provided these motivating questions that I've listed here. They're very general questions, but again, we just wanted to narrow down our motivation by using these questions and having the participants just work around these questions. So again, if you look at our agenda, you'll find these motivating questions there. But the ultimate objective was to generate more specific questions, which we did as part of this workshop. So, so day one looked something like this. We were in a U-shaped room, had really, and mostly we did was having several sessions, but 3 sessions associated with those topical areas, and where we had short presentations, 10 minutes per speaker, and had long open discussions for half an hour to 45 minutes related to that session. And we ended with a panel discussion where we had ecologists in the panel and just raising the issue related to usability. The second day looked a little different. We were more in a breakout groups and a working session. You can see people working in front of their laptops. Again, we had everything set up online on Google Drive, all these documents that people were working on, and you know, capturing edits in real time, etc. But it was really a working session to get to those questions and issues and just document the thoughts emerging from the workshop. So what are the products that can come out of it? I mentioned the workshop notes and you know, just some great note-taking that occurred during the workshop. And so everything was put on the Google Drive, and it's an evolving documentation. And so the idea was that once the participants leave, they can still work on these documents. So these are like the raw data set from which we will produce more refined work. So one of the things that we are doing right away is, you know, putting together this workshop briefing for publication in the AGU EOS report summary. And along with that, we also are preparing a supplement that really covers that important questions and the issues that were raised at the workshop. And so we found this was a good way to synthesize the things we really wanted to bring out of this workshop. And during the workshop, we also had the discussion of what other reports that can come out, and we believe there will be more focused reports with much more involvement of the workshop participants. Okay, so that's pretty much about how we did it. Are there any questions related to the how process? If not, I can get into what really emerged out of the workshop. And we'll do this more in a discussion mode, and Joe and I will kind of tag team on this, and Candida as well. We're all in the same room here. So,
so MTS, this is Joe. MTS has prepared these 5 topics on the next 6 slides that sort of follow the main outline of what some of the main points that came up in the workshop. This is Joe again. As with any complex and sprawling workshop, even in a day and 3/4, I think we all have slightly different impressions of what the main points were. And I didn't catch on the call who on the call actually was at the workshop.
I saw Helen.
Helen's on the call, but I don't have the list up in front of me. Is there anybody else on the call who was at the workshop? Well, Helen, you can say hi too.
Okay, hi. Sorry, I have to unmute myself.
That's good. I'm curious if anybody else on the call was at the workshop. Jeff, is Jeff?
Yep, I'm on the line.
Good. Okay, so we have a couple of people, but so most of the people haven't been there. So do you want to start into this?
Okay. So again, this was put rather quickly. There were, and we could have chosen any other issues that came out. But what I did was really took the wording from the briefing we have prepared, and it's kind of in its final stage for submission, and just used it as a template for the next 6 slides, and just picked some issues that comes out of it. So the issue number 1 that we put here is what kept coming over and over again, and it was that these high-resolution modeling output might be really key to improving our understanding of certain processes. So the emphasis on certain processes at finer scale under climate change. And so some of these things include processes related to snow and mountains and plains, phenology, etc., and issues related to orographic and very important in the Great Plains, the convective precipitation. So it kept coming out that we need to model convective precipitation well to really get to understanding and quantifying impacts, including those related to extreme precipitation. And we'll discuss convective precipitation separately in the next slide. So this is a little more general here, and the questions out here are, that kind of emerged, and Joe kept emphasizing to me, was that the sense that if you feel that your ecosystem response is sensitive to more detailed information related to these processes, and not just simply to, the means and climate variables and changes in those means, then maybe you should consider looking into the output emerging from the HRCMs, or the insights emerging from the HRCMs, and are they different from the statistically downscaled data set? So the ultimate question is, yes, when do we need to resort to HRCMs?
It was also really became clear that there's a high barrier to entry, a high barrier to using this output in an ecological context. And we'll talk about that more in the usability slide. But the point of identifying these processes, when, what are these models really excelling at? What are they just, giving you a small incremental increase in? That was what we tried to get at in this session, and I think we succeeded to some extent. A number of the participants, prepared special slides of the climatology or the variability of their models in our region, which was quite nice. Helen, among other people, kept coming back to the question of when do we use this class of models compared to statistical models. And we did not talk about statistical downscaling. That would have made the workshop unwieldy. But that was always the elephant in the room, so to speak, that we're all using statistical downscaling. Are you telling us that that's wrong? And the answer is not that it's wrong. It's that there are specific cases where we might want to push the envelope a little bit on our science and on our effort to be able to incorporate some of these higher resolution modeling dynamical models. But to choose it very judiciously, not just to go willy-nilly and say, oh, we don't have a regional model, we're not going to use it. We're not going to do it. We're just going to choose it based on the processes. So let's go into the convective one.
Can I ask you a question, Joe?
Oh, yeah.
This is Dennis. Just thinking about the convective precipitation schemes, one reason to move down that path is to look at sort of precipitation related to extreme events. But there are still limitations as we look at these regional climate models, because there's still precipitation is still uniform across the grid cell, right?
You broke up a little bit there. Precipitation is so.
I think you were saying this more like those drizzle issue in the GCMs. Or use the word uniform precipitation.
Nope.
Yeah.
What were you saying about uniform precipitation?
Across the grid cell still, right?
Oh, yeah. The question is, how do you interpret what a grid cell precipitation means, right? The model gives you a grid cell. You still have another layer of interpretation on top of that to get down to what happens at a site.
Yes, I would say that what Scott Denning and his modeling was showing, and this is Jeff just saying that it was the distribution of the rainfall events, which includes the extremes, that are important. I guess it sort of falls under convective precip, but I think maybe it's its own category as far as the kind of the tails of the distribution and the likelihood of those extreme events, which I think you're going to get from the high resolution regional models that you're not getting any downscaling.
Let me put it this way, Dennis. We approached it two ways. you can think of just all this model output that's sitting out there that we're going to plug into the ecosystem models. But the other level of this is, what are we learning from these high-resolution models that can be conceptually incorporated into things like scenario planning, that things like the relative changes in extremes, things like interaction with topography that may not be, usable out of the box as a grid cell value, but that may be getting more at how these extremes are changing. So what are we learning from this, aside from what we could just go and grab time series, right? And that was another theme that came in on the usability. It's very clear that there's a spectrum of the way the models get convective precipitation, starting somewhere in the 20-kilometer range all the way down to 1 kilometer. That as you get into that range, you start to get more realistic simulations of these propagating convective systems that move across the plains, for example. So it's not an either-or. It turns out that jumping to the convection resolving models, and that's the big thing, once you get past 4 kilometers, you're explicitly resolving the updrafts. You don't have a parameterization anymore for your convection. It's very clear that that it's not like a huge jump in realism, that there are people who work at the 12-kilometer to 8-kilometer range with these parameterized models who get very good representation of these storms. Yeah. That's all. That's one thing that came out, was that there's a spectrum of. It's not like an either-or. It's not like, we have to go to 1 kilometer or you get nothing.
But I just add to that would be, Dennis, you mentioned the scheme. So we talked about the different schemes to parameterize convection in GCMs, and even these coarser resolution regional models. And the agreement that came out was that depending on what schemes you are using, you're getting very different results. So that's one source of uncertainty using those different schemes for convection. But the other thing that came out was, at very high resolution, when you're resolving convection, are we having enough validation for that? So we are having problem with validation. And as Joe mentioned, even at 20 kilometers, we are getting aspects of convection that's probably good enough for most purposes. So we really have to go down.
May I break in?
Sorry?
May I ask a question? This is Chris Anderson.
Please, go ahead.
State. I was just wondering, I hear a lot of discussion about the climate processes, but did the ecology people and the scenario people discuss their concerns about certain processes that they're looking for different data on? For example, do they know that they need some new data about daily rainfall or sub-daily rainfall? And was that part of this discussion at this workshop?
Right. Yeah, we're all nodding our heads here. Yes, I mean, one of the questions we kept asking colleges, and we kept getting all kind of answers, was, what kind of data set you're interested in, and it depends on the kind of models you're using. So they're all, as a climate scientist, we realize there are different kinds of ecological models, and they deal with different kind of data sets, and so depending on which model you're using, the data set varies, but in some cases, yes, daily and sub-daily scale data sets are needed, and that's kind of one of the strengths of the regional climate models, that they provide the dynamically downscale data sets include much of these high temporal resolution from sub-daily to daily time scales.
They theoretically included in the data set. It's in the models. Whether it's available for download is a different question.
Yeah, but NARCAP had 3 hourly data sets.
Yeah, yeah. So that's a very, very good question. There was a lot of discussion about sort of the dance that's done between ecological modeling and climate variables, and that a lot of ecological models, because of their own data limitations of what's been collected over the last 50 years, are often based on seasonal or monthly, very large-scale climate correlates, climate predictors, very large temporal scale, fine spatial scale, but large temporal scale is an often compromise that's done in ecological modeling. And for that, statistical methods might work quite well. But it's a dance that continues, and that as more climate information becomes available and more sophisticated ecological models come, I think that dance is going to continue. So part of this was to sort of also ask the open-ended question of not only what are we doing, but what could we do down the line, and several, where are we working towards in this effort. So your point is very well taken about, I wouldn't say the need for this, but the desire to go look at processes at these scales and see how they affect how they might be incorporated. I think that was certainly discussed, but it wasn't expressed as a we need this. Definitely, right? It was expressed as we have methods that we're using now that we think have strengths and weaknesses, and maybe we can address some of those.
And regarding the scenario planning issue, there's a slide later on that has something on it, but what came out was that at least for scenario planning work, we can incorporate much of what's coming out, much of the insights coming out of these high resolution modeling relatively easily. So in terms of how, if these high resolution models are telling something different in terms of how extreme precipitation may change in future, you can incorporate that relatively easily in scenario planning than maybe other form of ecological modeling.
Great, thank you.
Okay, great, thanks. So again, just the last word on the convective precipitation was, the issue is how important is it to get it right for much of the impact assessment. And I don't know, we have all the answers here, but it was thought of as we need to get the process right for much of the impact. That's what I came out with from the workshop personally.
And I came out with the fact that certain things were identified, such as there was erosion, for example, where the cultural resources for the park are threatened, things like erosion events. There are certainly applications where you're going to need this. I'm a little bit more on the fence about whether it's needed for a lot of other ecological applications, much more on the fence on that. But again, to focus in on those sweet spots where you say, well, we really can't do this without knowing the extremes, and get to the next slide, which is about extremes.
Right. Again, this is connected to convective precipitation. Much of the convective extremes, convective precipitation, much of the extreme climate is happening in the warm season and driven by the convective process. So the issue with extreme precipitation has been, are we quantifying it correctly, robustly? And from the results we have until now, we generally find that, first of all, the extreme precipitation is a complex physical process, and the belief is that the GCM is not capturing it reliably, so it does not translate into the statistically downscale data set that most of us are using. But on the other hand, in terms of insights, the relative low sample of HRCMs that provide this information kind of generally show that there's increases in the heavy precipitation events and the climate change, and these increases are generally greater than what the GCM projections are. So in a way suggesting that resolution matter in terms of quantifying extremes. But again, how do we validate that? And do we need enough samples before we kind of generate more consensus? Your thoughts?
Yeah, I wanted to say there's two other things that come to mind from the workshop on this issue of extremes. One is that this is really a forefront of climate science right now. Linda Merz talked a little bit about some work done in England that's led by, among other people, Elizabeth Kendon, where they're taking a 1 kilometer model embedded in a larger, as it was shown in that initial graphic, and running it for 150 years, and looking at how extremes are simulated and how they change into the future, and finding quite striking issues about the sub-daily, about the extremes that happen, the implications for flash flooding. But this is the forefront. You're going to be seeing more and more of that over the next, 5 years. That is where the field is going, and it's kind of crystallizing around that. We have some work that's been done on that here piecemeal, but we're finally getting to be able to say things about more systematically about the climate issues with that scale. So that's more of a five-year, like where we're going with that. as a field. And the second thing was mentioned, we didn't talk about any of the slides here, was some of the work being done in Roy Rasmussen's group is not necessarily involving a full-on model, but they have a stripped-down version of a dynamical model that they've developed, that Ethan Gutman's developed. And that's for use at the fine scale of orographic precipitation, particularly snow. It would not handle convection precipitation at all because it strips out the nonlinearities, most of them. But it's a very clever model that they've developed. It's probably worth looking into for mountainous areas. And it will blend the best of statistical and dynamical, to put it in a word. So I actually thought that was kind of interesting. But again, cutting-edge work, just starting to come out there. You will have to learn how to run his model in order to get it to do stuff for your area. So it's not just a data set you can download. Again, a fairly high barrier to entry, but pretty interesting work that came out there, I thought.
Hi. Thanks, Joe. Moving on. Of course, we didn't leave out drought, and that was really part of what we thought was the session on land surface processes and feedbacks. But again, drought relates to convective precipitation quite closely, especially in the Great Plains. And so, the land surface feedback relates to how precipitation occurs. So the fine scale processes have a lot of feedbacks with the land surface and the atmosphere at those scales. And so, again, this kind of sense out there that, we need insights from these models to be incorporated in our understanding of impacts in the future. So with droughts, it was really about how would the frequency, intensity, and just the manifestation of drought will change in the Great Plains, and it was felt that issue is quite salient to that region. And we feel that the regional models and these high-resolution models can provide, more physically robust insight into the phenomena, and primarily because we feel that they represent the land surface feedbacks more accurately. But again, I mean, there is a level of uncertainty in terms of how are we, simulating processes related to the land surface. Are we capturing changes in soil moisture and the soil moisture connectivity to the atmospheric process adequately in these regional models too? And so that challenge remains, but probably that's the best place to start. So that's what I mentioned down there. Again, the other idea was at what spatial and temporal scales do we really want to focus on? What are adequate for impact assessment, and do we really have to go to 1 kilometer here? So,
and there were several interesting presentations. They give you a sense of what can be done with these models, but then again, a very intensive work working with a modeler. Things like looking at changes in land surface properties. And I know one of the funded research here is actually looking at land changes in land use. Also resolving some very fine-scale relationships between crop cover and temperature, for example. But again, that's really intensive work, and has to be done sort of as a funded project, not necessarily as something you can just download the data set. There were still large biases in these regional models in what happens with soil moisture and drought, and so there was a sense that you have to be very careful about using these models. That they're not all. I mean, there was a nice comparison between basically, observationally constrained version of what evapotranspiration is in Nebraska, and what the models were showing for the same period, with actual, weather boundary conditions on the edges. So it actually was supposed to reproduce the same evapotranspiration, and it looked very different. This is what Mike Hobbins was showing. That you see very, what Clint was showing. Showing very, very different patterns, indicating that the models are probably not getting the processes as right as we think they are, as they should be. So great caution at this level. And again, not entirely clear what you're getting at the fine spatial scales. but the flexibility of changing out land surface, or also, for example, looking at the impacts of irrigation. Large-scale irrigation is important in certain areas where it actually affects the regional climate, and that's certainly an area where these models excel, where statistical models are just going to really not work. So that was identified as one specific topic.
Yeah, I guess my message is just kind of paying close attention to what kind of information is emerging from these experiments.
And we still have to go comprehensively through the notes from the workshop and write them up. We've gone through them at a level where we've picked up some high points, but there was so much discussion and good discussion, we'll have to do that for the further write-up. So.
Okay, and lastly, it's the issue of usability. And again, these are themes that are connected or disconnected, but what generally felt was that there was a gap between the advances that were achieved in the regional modeling community and the products that were available for application, and as that came out quite a bit. Another thing that came out was that the HRCMs really can provide these physically consistent statistics of climate feature of interest, or its extreme behavior, so climate means and extremes, but in a much more nuanced way. So that information can become available. One issue was, of course, for scenario planning, for example, do we have enough samples and to choose across scenarios? Are they providing enough range that comes out of GCMs? And they may be they may not be as robust there, but they are providing something that the GCMs are not in terms of processes, and can we capture something from that to inform our scenario planning? And of course, importantly, insights related to non-linear and non-stationary changes in physical processes, like extreme precipitation and phenology of snow cover, etc. Those could be quite insightful, and that could be, easily incorporated into scenario planning, as I mentioned earlier. Another issue that was quite salient in terms of usability that emerged was the call for well-documented and more easily accessible data sets from these regional modeling efforts. And the other link to that is, if we have that, they can actually provide a prompt to impact modelers to revisit and reconsider their own models and the variables they are using in their models. And so it could feed back on ecological modeling committee to redesign their models and be more sensitive to processes. And the very reason that the ecologists are not using models that incorporate a lot of climate information is primarily because that kind of information was not available in the past, but that can change in the future, including CMIP-5 models, which are providing a lot of this information, although at much coarser resolution. And lastly, of course, no-brainer that we definitely need an improved and continuing engagement between the modelers and user community, and maybe a climate service group like North Central Climate Science Center can have a role there in having that engagement happen. Joe.
At the very end of the discussion on the second day, basically a couple of projects there was enthusiasm for connecting a couple of funded projects in North Central with some of this data, working with the scientists on a pro bono basis, basically, to try to incorporate some of these insights. One is through the scenario planning group, which, again, because it's a relatively low-cost, low-effort way of doing it, it's just really learning, it's really just crystallizing what we learn from these high-resolution models. And to put it, and I guess Nick and Gregor really put it to us that scenario planning is about divergent futures. And the idea that statistical models may be actually missing some of those divergent futures because they don't handle things like extremes in a systematic way, that it's a good thing to bring in divergent futures that come out of regional climate models. So that was one project. Also, Katie was saying, what Renwick, working up with Ben Poulter and that group, was interested in actually taking the other tack, which is actually trying to incorporate some of the time series from some of the sets of model runs that are just sort of sitting out there on scientists' computers, and trying to work with that and through some of her ecological modeling efforts. So we have sort of two good candidates. There was some other talk. So David Roop from Oregon made the very good point that you shouldn't just willy-nilly go into this. You really want to take a deep breath and say, okay, let's make sure we're going about this in a way that's scientifically valid, that we're not just adding one more data point that's just kind of picked at random from somewhere else, that we're actually, constructing, for example, with Katie's work, to construct a fair comparison between statistical and dynamical methods. So that takes some thinking. That would be a more involved piece of work to do that. But those two seeds got planted, as well as other discussions that happened between modelers. Rao Kotabarti, who's from Argonne, also offered to make some of his output available if it's not, again, if it's not a lot of work on their side. So we started the seeds of that. We definitely need to follow up on that.
Right. And I mentioned, so we're really done with our presentation here, but just a few more points. That this is an evolving process, and although we haven't shared the Google Drive with all of you there, it's all the participants are, have access to it, and the idea is, again, to take it to different purposes from here. But we hope to build on this workshop into our research in the near future. So, so you heard from the climatologist in the workshop. Since Jeff and Helen are there, I'm just wondering if they have any other comments to share before we get to the questions.
This is Jeff. If I could just maybe chime in and related to Chris's question, I don't think this type of workshop is typical in that it did bring in the ecological modelers kind of on equal footing, or just as important as the climate modeler. So it was kind of an extension, or it's kind of different than maybe a climate modeling workshop, that it's focused on the ecological modelers. I heard quite a bit from different climate modelers saying, well, geez, okay, I didn't realize you guys needed that, or that's what you're concerned about. So I thought it was really healthy and productive in connecting the two. We also then even made this kind of spreadsheet. I don't know if you guys, the hassle would make up, but on that Google sheet, we've got the different modelers that were there kind of in a matrix across the different ecological projects that might be able to take advantage of those specific models, or that at least explore what the marginal benefit is of using those models into those the ecological response modeling and the ultimate kind of decision or information they're looking to get. So I do think that it was kind of that nexus between the ecological modeling community and climate that was the unique feature, and hats off to Joe and Candida and MTS for bringing them in, because I think there was quite a bit of exchange in that regard.
Thanks. Helen?
I guess what I'd say also kind of has to do with that question of temporal resolution a little bit. But I think a lot of the workshop was, among the climate modelers, the big question was what resolution, is needed, or how do the results differ between 4 kilometers and 12 kilometers, and that kind of question. And I think, like you said, Joe, the comparison with statistical downscaling was kind of like the elephant in the room, and that wasn't done as explicitly in most cases. And I think that because of that, the question of, okay, well, where does it matter in the climate data, has to kind of come from the climate modelers, and then the ecologists kind of, in every system we need to know our own system sensitivities to these different variables. A lot of the systems I've worked with, we're using things like seasonal, total summer precipitation, that kind of thing. And it seemed like for those kinds of variables, at that big time scale, as you said, it's not probably as useful. And so I guess, yeah, I would echo the need to sort of really clarify the temporal scale and the variables that it makes a big difference for.
Right, and I think I'm not sure if we have a clear idea of how to really tackle that question. It was left out of the discussion because the point of this was, I'll be honest, going into this, I was a fairly big skeptic of using regional climate modeling for ecological applications, just because, and I presented in my opening talk an example of an effort in the Colorado Plateau with the rapid ecoregional assessment, which I thought kind of crashed on the rocks of all the difficulties you have using regional climate modeling, right? I mean, and I came in wanting people to convince me that there were places that it might actually be useful. I think by the end of it, perhaps because we were only talking about regional climate modeling, this high-resolution modeling, we all came up with very positive feelings about it. And I echo what you're saying, Helen, is that we shouldn't then say, oh, then statistical is not useful. I think it's very useful. How do we get to a fair comparison? That's a lot of work. So I think building that into a project is probably the way to do it, right? Having a few pilot projects say, well, we think it might be useful, but let's do a fair comparison.
Mm-hmm.
I think doing it systematically is going to be, too much. I mean, that's a huge. A workshop on that would take a week,
Yeah.
We would certainly address it from what we have from the workshop notes, and make sure that that question stays front and center. That it's not resolved. That that it's not a resolved question in the sense, talking about a different kind of resolution. But I think we have a lot more insight about where to explore, and opening the eyes of some of the ecosystem modelers as to what we might be able to provide from the climate perspective on some of these more difficult variables. And I suspect there will come up these aha moments where it's like, oh, I didn't know you could tell us that. Good, we can now sort of tackle how this prospect, we can at least explore how this fine-scale process might work. I hope that happens in the future. But
so along those lines, this is Dennis, were there some experiments that were contemplated looking at the feedbacks between the land surface and the high resolution or the regional models? I mean, there are aspects of looking at land cover change and how that affects the land surface, albedo energy dimensions, the changes in land use related to consumptive use of water from groundwater that would influence evapotranspiration in a way that if you only looked at rain-fed agriculture, it would have a big impact on sort of that land-atmosphere boundary conditions. So it seems like there's room for additional, maybe a workshop on looking at sort of the ecological feedbacks, especially post-disturbance like fires, the contribution of smoke to the atmosphere. Topography is another one, to where in complex terrain you have things like cold airflow, what that does to sort of ecosystem dynamics or the ecosystem feedbacks. So there's just number of interesting questions that emerge in this whole land-atmosphere interplay, and it's not just a one-way direction of getting better climate information in a higher resolution to drive ecological models, but to me the interactive exchange in actually coming with a fully coupled model would be quite useful to think about in a way of new directions.
Right. No, that's a great point, Dennis. In fact, I did raise issues related to how good are these high-resolution models in simulating these feedbacks that you talked about, and the answer was probably not very well, and so that's one place for improvement. the workshop was very small, and we didn't expect to get solutions out of the workshop, more so as what are the issues and what are the right questions, what questions should we be asking, and as relates to the region we are focused on. So I think the regional emphasis was important, that we thought comes out when we do such exercises and the questions like the ones you asked.
There were presentations studying historical patterns of land use change and how those have been modeled. I don't think there was anything really about future land use changes and irrigation changes that were presented, although I know that work has been done. And keep in mind that the feedbacks happen at a regional and even continental scale. It turns out that you can change the total amount of precipitation in the upper Midwest through radical changes in land cover and land use. And so the feedbacks are not always local, which is why you do need one of these larger, dynamical models to explore this. I think your idea of working towards a focused workshop on that issue in a year or so would be a really good one, honestly.
Yeah, I'm just reflecting on some of the classic work that Wilkie Sr. did and I did with a joint graduate student PhD project with, what's her name? Anyway, it is this fine scale land use feedback or land cover, land surface feedback is an interesting topic.
Yeah, we tried to get more on that. There is actually some cutting edge work that they haven't quite done yet in the Pacific Northwest, where they're coupling ecosystem land surface models at fine scales with a whole suite of, a large ensemble of climate models to get at the uncertainty question, and that also pushes you towards the extremes question. We have a large ensemble. Some of them go and do things that are really quite extreme. So there is some cutting-edge work on that. It really came out as much more of a question mark in this workshop than we expected. There's still issues of bias in these models, that the precip or the hydrologic properties of the soils are not giving you the right feedbacks. So it was very, that was less satisfying than I hoped it would be for this. That land surface feedback question was less satisfying than I hoped it would be for this workshop, to be honest.
And to be honest, I think the discussion on feedbacks was rather limited at the workshop, and it's probably a good idea to have a workshop totally dedicated to that, maybe in the future.
And I think that's an excellent idea to work towards something like that, and maybe incorporating the comparison between statistical and dynamical. What do you get without the feedbacks, what do you get with the feedbacks would be a good way to go about that.
Any more questions, or should we move on to something else?
I guess if there's no more questions, we can move on. We don't have much time, but could we have maybe just a 2 or 3 minute updates from the adaptation team and the impacts team?
Is Shannon with you?
She's not. I think she's en route to Santa Fe and should be here this afternoon, but not here yet.
Okay.
Do you want to give a little? This is Joe. Candida and I went up spent several days along with Shannon on the Wind River Indian Reservation at a wonderful field trip. And pardon me? Reconnaissance. Yeah, reconnaissance at the attending their all-hands meeting for their drought project, but then getting a full-on tour of every water, not everyone, but a lot of the water resources and just the landscape of that area. Do you want to say a couple words, Candida?
Hi, this is Candida. So yeah, it was good for Joe and I to get a sense of the nuances within the Wind River Basin, because there are sub watersheds within the larger system that have very different hydrological behaviors, if I can put it that way, and getting a feel of the lay of the land was really important for us to redefine our approach to contribute to the project. So yeah, being there actually really matters.
And getting a sense for a lot of the institutional issues that come up with water management and how that affects the scales that they're looking at, temporal and spatial scales, exactly what kind of information is going to be useful, what are the things that we were thinking of doing that would just totally, not be useful. So it was really, really a good trip, and not just for the fact that it was really nice to meet and interact with all the people up there, but it was also really conceptually very useful for this project.
And I think, Candida, do you want to talk about your evapotranspiration research?
Sure. Just a quick update. I don't want to take up somebody else's time. We've been making progress on the comparison of different potential evapotranspiration approaches, and by that I mean comparing a physically based approach, as Penman-Monteith is, to a temperature-based approach. In this case, I'm using Hargreaves, and how they are represented in a CMIP-5 climate model. And I'm starting with the GFDL model, and we'll later on repeat it for other models, but to test drive the approach, I'm starting with this just one model, and we're already finding some substantial differences that will be important to applications projects.
And some of that research we can apply to some of the study regions like the Wind River, and just kind of what are the models telling about that region in particular. So that's all from us. Yeah.
Okay. Andy here. I could give a quick update on impacts if appropriate.
Yes, great. Go ahead, Andy.
Yeah, so Arjun and I had a nice conference call with Jennifer Weldon from the Wind River Drought Project. Turns out she spent quite a bit of time in Nepal and speaks Nepalese well, so she and Arjun hit it off. It was interesting to learn about the project and the opportunity to contribute data sets. We've just finished a technical report on land use change across the North Central Climate Science domain, and we'll be sending that out to each of the projects with their information. And as we discussed last time, we're happy to provide data sets for their study areas as they would like. We also had a workshop on basically how to analyze change in land use using the latest USGS data sets, and then having that as a basis for projection under future IPC scenarios, and made good progress on it. We, I guess, finally have a workshop scheduled for next week on ecosystem modeling, and this is one that Brian Miller will be joining us for, which we're excited about, and Ben Poulter's lab, and then 2 or 3 other labs from the region. It's basically aimed at comparing different modeling approaches and trying to bring them together, particularly in a climate change and management context. So I think those are the main activities we've had this month.
Andy, let me ask, this is Jeff, just so we just heard from the climate folks in the workshop they had. Would you be interested in summarizing the results of next week's workshop at an upcoming monthly check-in?
Yeah, that would be, I think that'd be interesting, and I could talk to Ben about sharing that.
Great. Why don't maybe just after you talk to Ben, let maybe me and Jill know what month would be appropriate or where you could fit it in. We can iterate on scheduling it.
Yeah, good.
Good. Appreciate it. Thanks.
Okay. Thanks, Andy. Dennis, anything to add on adaptation?
I guess on the drought area and actually social ecological systems, we have 2 new people here within the, I guess, associated with the center. Amber is working with Rudy, Amanda. And Shelley working on ecological drought just started as well. So we'll be hearing from them probably in the future. I think in looking at some of the opening up additional discussions with NOAA on their resilience toolkit, both from the socio-ecological point of view as well as just using it to look at response strategies, impacts and response strategies within the region, and how we might use that with various user communities. I know Jeff has had a number of discussions, and I've had separate discussions with other people at NOAA, so we're going to try to get our heads together around how we might integrate these things, possibly doing a regionally focused activity on that. That's it for now. I guess the question for everyone, could you let us know if you're going to AGU and to see if whether or not we want to get together there or not, share ideas and just to discuss things.
Should people communicate with you, Dennis, or Jill, or is anybody the key contact on AGU information?
Be that? Or you want?
Sure.
Yeah.
People can contact me, and I'll.
You want to just send out an email?
Yeah.
So Jill will send out an email request, and then we'll just kind of coordinate and see who's going to be there.
Okay.
That's a good idea. Thanks, Jill.
Sure. Okay, and I just have two more quick announcements before we get off. The first is thank you if you've updated the monthly check-in spreadsheet. If you haven't yet, please try to do that soon. There are a few projects that are requesting information from FSAs. Nina's Southwest Colorado project, the Wind River project, and adaptation. So I think the best thing would be to check out the spreadsheet and communicate with each other offline if need be. And then secondly, for the November and December check-ins, we wanted to have updates from our funded projects. So for November, updates from the 2015 funded projects, and in December, updates from the 2013 funded projects. And both of these check-ins are going to be held 1 week earlier than scheduled normally because of the holidays. So November is going to be November 17th, and December is going to be December 15th. So mark your calendars for those change of dates. That's all. I wanted to thank MTAS and Joe and Candida, and I guess we can sign off now.
Thank you.
Yeah, thanks a lot. That was good.